Now let us show that change in potential energy, is equal to what? Minus G mm over what? Over R. Now, imagine a system, okay? Let's say Earth and a planet. Maybe Earth and another planet. Let's say this planet Earth, this is moon. Let's say this is the moon. Or let me not use the moon. These are just a planetary body, okay? So this body now is at infinity. The position of this body is at infinity, okay? This is at infinity, okay? This is infinity. Remember, from here to here, extending to infinity. Now there is another orbit, which is what? R, okay? So that is the point. This point now is R, okay? That is from here to here. The distance from the center of the Earth to this point is what? R, okay? So just know that this point is R, okay? Why this point is what? Infinity. This one is R, okay? So now, according to the definition of gravitational potential energy, it is defined as the work done in taking a mass from infinity to this point. Now let us calculate the change in potential energy, which is, I told you that I want to verify this formula, that change in potential energy is equals to this. Now, at infinity, the potential energy, that is when R is equals to infinity. Remember that work done is equal to what? Force times distance. Okay? So now, work done is force times distance, which is equal to G mm all over R times distance R. Okay? cmm over r squared, times this. So cancel, one r cancel, so equals to G mm over what? Over R. Okay, so when the radius is at infinity, R is equal to infinity, that means it will be equals to G mm all over what? Infinity. So which implies that the work done is equal to 0. So at infinity, the potential energy at infinity is equal to what? 0. Do you understand? Potential energy is mgh. Okay? Potential energy is mgh. PE is equal to what? mgh. Okay? So G is equals to gm over r squared. Okay? And the height is at infinity. Do you understand? That is, I'm trying to calculate the potential energy at this infinity. So potential energy, the first potential energy will be, that is m times gm over r squared. Okay, then gm over r squared, then times, is mgh times r. So we now have PE. The first potential energy is gmm over r. Okay, gmm over r. So if r is equal to infinity, we now have that PE is equal to what? Gmm over what? Infinity. So that means PE is equal to what? 0. Potential energy at infinity is 0. So now let us calculate the potential energy at this point R. So at this point R, from this formula, GMM, PE equals to GMM over R, from this equation now, we now have the second potential energy, that is P. Let's call this one PE1. Let's call this one PE2. So the second potential energy will be equals to GMM over what? Over R. Remember, it is the point R. So now let us now calculate the change in potential energy. Remember, potential energy increases with what? With height. Okay, so it means that the potential energy at infinity will be greater than the potential energy at this point R, because it increases with height. Do you understand? So now let us calculate the change in the potential energy. So the change will now become, change in potential energy will now become equals to 0 minus this one, G mm over R. So the change in potential energy, PE, is now equal to what? Minus G mm over what? Over R. So which is the work done? Do Do you understand? So which is the work done? Remember, I say that change in potential energy is minus Vmm over R. Remember that work done, see the equation, see remember that equation that work done is equals to what? The negative of the what? Of the change in what? Potential energy of a system. Do you understand? Or the potential energy of the gravitational system is negative of what? The work done. Okay. So do you see? So whenever there is a change in potential energy, it will give you the same expression. Do you understand? So these are the like other perspectives of viewing and understanding the whole thing. I hope it's very clear.